Good morning, ladies and gentlemen. This is 33rd lecture of the course, and in this lecture we intend to discuss the comparative scaling techniques. As we are aware that there are comparative scaling techniques and non-comparative scaling techniques. So here in today's lecture we are going to discuss the comparative scaling techniques. So first we are going to see what do we mean by the comparative scaling techniques. The comparative scales involve direct comparison of stimulus objects. The comparative scale data are interpreted in relative terms and are measured on ordinal scale. The technique is non-numeric scaling technique, as ordinal data cannot be used for numeric operations. So, these are the basic traits, these are the fundamental qualities of the comparative scales, that in this kind of a scale there is direct comparison of the stimulus objects. In this kind of a scale, data is interpreted in relative terms and are measured on an ordinal scale. So, comparison in relative terms, interpretation in relative terms, and the ordinal scale, these are the characteristics of this comparative scaling technique. Further, the technique is non-numeric scaling technique, as ordinal data cannot be used for the numeric operations. So, for example, respondents are asked whether they like to use toothpaste of brand A or brand B. The respondents have to choose one out of A or B, even if there is very small difference in their liking of the two brands. So, as we saw yesterday, the whatever the smaller difference, the respondent have to say either he prefers A to B or he prefers B to A. So, similarly, when we take the case of say two brands of milk or say two brands of butter or two brands of say car, so the respondents have to choose one out of A or B, even if there is very small difference in their liking of the two brands. That is what we mean by the comparative scale. The comparative scales are subdivided into three important techniques. Number one, the paired comparison. Second, the rank order. And third, the constant sum. First, we discuss the paired comparison. In this method, the respondents can express their attitude by making a choice between two objects, say between a new flavor of soft drink and an established brand of the drink. Say a new brand of milk and an old established brand of milk. Say a new brand of butter and an established brand of the butter, or a new brand of the cycle and an old brand of the cycle. So we have this, that the respondent has a choice between two objects. However, when there are more than two stimuli to judge, the number of judgments required in a paired comparison is given by the formula n is equal to n into n minus 1 by 2. This is a universal formula for the number of judgments in a paired comparison. So if it is 2, then obviously we can see from the formula that there would be one judgment, whereas if there are 3, then from the formula we find that it would be 3, and if the objects are 4 to be compared, then the judgments would be 6, and that way we go on calculating the number of judgments. If it is 5, then it should be 10. So the formula capital N is equal to n into n minus 1 by 2, where gives the number of the judgments depending upon the number of objects. So the here n is equal to number of judgments, whereas small n, the capital N is equal to number of judgments, whereas the smaller n indicates the number of stimuli or objects to be judged. That is something which has been done easy to check, that how many judgments have to come from the paired comparison, or depending upon the number of objects and the stimuli. For instance, if there are 10 suggestions for bargaining proposals available to a workers' union, there would be 45 paired comparisons that can be made with them. However, when n happens to be the number of judgment happens to be a big figure, there is the risk of respondents giving ill-considered answers, or they may even refuse to answer. It is natural. If we give people to compare between 10 objects, 10 stimuli, then the number of judgments is required is 45. So most of the time they would be either refusing to cooperate, or they would be giving any answer without any thought and without any serious consideration. So we have to reduce the number of comparisons per respondent by presenting to each one of them only a sample of stimuli, or by choosing a few objects which cover the range of attractiveness at about equal intervals, and then comparing all other stimuli to these few standard objects. So what we have to do, that we have to limit the objects or stimuli to a few, and of course this should represent or cover the attractiveness, and they should be at equal intervals, and then compare all other stimuli to these few standard objects. We, when we proceed ahead, we shall be getting the gist of it. So, the paired comparison data may be treated in several ways. If there is substantial consistency, we will find that if x is preferred to y and y to z, then x will consistently be preferred to z. If this is true, we make the total number of preferences among the comparisons as the score for that stimulus. So, this is a very important condition for the paired comparison, and that these choices must not violate the transitivity rules. That is, if x is preferred to y and y to z, then x would consistently be preferred to z. This has to be true, and if this is true, we may make the total number of preferences among the comparisons as the score for that stimuli. It should be remembered that paired comparison provides ordinal data, but the same has to be converted into an interval scale by the method of the law of comparative judgment developed by Mr. L. Thurstone. So, suppose we have 4 proposals that some union bargaining committee is considering. The committee wants to know the union membership ranks these how the union membership ranks these proposals. For this purpose, the sample of 100 members might express their views as shown in the following table. So, here in this case, we have 4 proposals with a union bargaining committee to consider, and they want to get an idea that how the union members react to these proposals, and this response pattern of 100 member paired comparisons of 4 suggestions, 4 stimuli for union bargaining proposal priorities are given in the table here. So, we observe the table, we find that first of all there is 4 stimuli, and then there are 100 members. So, we find that one member would be giving 4 into 4 minus 1 by 2, that is 6. 6, they would be giving 6 opinions, one person. So, in total there should be 600 opinions, and that is what we have in the A, B, C, D here. In the, of course, when we observe this, we find that A is, of course, A cannot be compared with A, B cannot be compared with B, C cannot be compared with C, D cannot be compared with D, and this is why you have dashes here. And A preferred to B is 65, then responses, then A preferred to C is 32, and A preferred to D is 20. Then a similar way, we find that B preferred to A is 40, B preferred to C is 38, B preferred to D is 42. C preferred to A is 45, C preferred to B is 50, and C preferred to D is 70. And D preferred to A is 80, D preferred to B is 20, D preferred to C is 98. When we add all this, then we find that these are 600, because there are 4 stimuli, 4 proposals for the bargaining, and out of these 4 each one has then, because the proposals are 4, stimuli is 4, so we will have 6 combination of preferences, 6 paired comparisons, and then since there are 100 members of the committee, so we have the 600. So comparing the total number of preferences for each of the proposals, we find that C is the most popular, followed by A, B and D. C has 168 preferences, whereas A has 165, D has 132. So, of course, in total it is 600, but then C is the most popular, followed by A, B and D proposals. Then the rank order, there is rank order, we observe that after the total there is a row which gives rank order. So it gives C rank 1, A rank 2, B rank 3 and D rank 4. The rank order shown in the above table explains all this. Then by following the composite standard method, we can develop an interval scale from the paired comparison ordinal data given in the above table, for which purpose we have to adopt the following steps in order. So now the job is to use this data for developing an interval scale from the paired comparison ordinal data. How it is to be done? It is given by the formula that is called the column mean. So using the data in the above table, we work out the column mean with the help of the formula given below, that is MP minus C plus 0.5 n small n into capital N is equal to, we observe that C has the 165 score, then 0.5, n is 100, that is number of opinion makers, and then 4 stimuli, and again n is 200. So in the formula we find that This MP is the mean proportion of the columns, whereas C is the total number of choices for a given suggestion, for A, for B, for C, for D, and then N is the number of stimuli, that is proposals in a given problem, and N is equal to the number of items in the sample, that is 100 to us. So, by calculating on this formula, the column mean for the stimuli C is given as 0.5375. So, that way we will calculate all the MP of the all stimuli, the column mean. So, the column mean for A here is 0.5375. The column mean for B here calculated in the same way is 0.4625. Column mean for C here in the same way with the same formula is 0.5450, and the column mean for the stimuli D is 0.4550, and then depending upon these we have to find the Z values for these. The Z values we do not have to calculate, these are given in the back of all the important statistical books. So, we have to write the Z values here and then the R values. So, the Z values, now the column means have been shown in the MP row in that table. The Z values are for the column mean are secured from tables giving the area under the normal curve. When the MP value is less than 0.5, the Z value is negative, and for MP values higher than 0.5, the Z values are positive. These values have been shown in the ZJ table. Then, as the ZJ values represent the interval scale, 0 is an arbitrary value. Hence, we can eliminate negative scale values by giving the value of 0 to the lowest scale value, which for us is 0.11. We are looking here, whereas in our example, which we consider as take as equal to 0, and then adding the absolute value of this lowest scale value to all other scale items, the scale has been shown in the RJ row in the above table. Take out the table, and here we have the RJ values. How it has been arrived? It has been arrived by considering or putting the value of the minimum Zj, that is minus 0.11 to 0. If it is so, then of course we go on adding plus 0.11 to all other, because when we have added plus 0.11 to minus 0.11, then it has become 0. So, go on adding the plus 0.11 value to other columns. Then it gives us the Rj values. So if we add 0.11 to 0.09, it becomes 0.2. If we add 0.11 to minus 0.09, it becomes 0.02. And if we add 0.11 to already in the C column to 0.11, then we have the score, the Rj score as 0.22. So now what we observed that for all the stimulis we have collected the Rj values in this way, giving them the equal intervals. So graphically we can show these values here. We can show this interval scale that we have derived from the paired comparison data using the composite standard method as follows. What is that? On the 0 point we have D, then we have B which had the Rj of 0.02, then we have the A which has the Rj of 0.20, A, and then we have the C which has the Rj value of 0.22. So depending upon the Rj values, we have fixed the position of these stimuli. So this has become a kind of interval scale that we have derived from the paired comparison data using the composite standard method, which is shown in this figure. Although from the figure and from this formula and the table, it may seem that it is very hard to calculate, or it requires very sophisticated kind of analysis or statistical formulas, but once we observe it minutely, we find that there are very small arithmetic calculations which are provided to us. MP has been the column mean. We add the score of the stimulus, and then we have the average, and similarly the MP was calculated, which did not, the MP was calculated which is not very typical or difficult formula. We have done it like this is a small formula which only requires very small arithmetic operations. So it's also calculating MP is also not difficult. Zj has been given this value, in fact beginning from the rank order, we in fact we have given the rank depending upon the the score of the various kind of stimuli, and then the MPV has calculated from this small formula which requires only a small arithmetic operation, and the Z values they are given in the table. We 0.5 less than 0.5 it is in minus, and more than 0.5 it is in plus. These are available in the tables, in the back of the books, anywhere in any statistical textbook. And of course, then we make the RJ by making the minimum score at 0, and then of course adding the same to each of the ZJ scores, and that way we have arrived at this graphical figure which gives us this interval scale that we have derived from the paired comparison data using the standard method as follows. So, what I wanted mean to say that although apparently it seems that it is very difficult and sophisticated, but no, it is not that. It only needs a small arithmetic calculations, and with the help of a small arithmetic calculation and the formula and the methodology that was given in this, we can always arrive at this kind of a scale in very a very small effort. So I wish I have been able to clear you this concept of the paired comparison. Next is the rank order, to rank their choices. As ranked scales are faster and easier than the method of paired comparisons which we discussed above. For example, in a prompt that lists several items, only some of them may require ranking. As the method of rank order simply requires ranking of 10 items, only those items that interest a respondent may be ranked, as opposed to the larger number in paired comparison. So here we have given a choice to the respondents that whatever they feel they rank. If they feel some of the stimuli not in their views to be ranked, they have the freedom not to rank them. Whereas in the previous system, in the previous method of the paired comparison, we did not have this option, and all the stimuli had to be ranked by the respondents. So in this rank order, it simply requires ranking of 10 items, only those which which interests a respondent, they can be ranked. So the number of the comparisons reduces. Moreover, a complex preferences are not needed, in which case the respondents may be asked to rank only their first, say 3 or more. To secure a simple ranking of all items involved may be more than 4, say it may be 15 or 20 items. So of the stimuli 15 or 20 items, we may request the respondent to only rank their, say, first 3 choices. Then there are methods through which we can as well develop an interval scale of these data from ordinal data, and therefore rank order gives an ordinal scale with all its limitations. Then there may be problem of respondents becoming careless in assigning ranks, particularly when there are more than 10 items. So in large number of items, it is natural that the respondents may develop lethargy and become careless. Then we come to the constant sum. What is the constant sum? The constant sum scaling technique is used to assess the relative importance attached by a respondent to the stimulus objects. So, the respondent gives certain points to each stimulus objects out of a fixed sum of points. The fixed sum is usually taken as 100, but it could be some other value also. What is constant sum scaling technique? It is very easy, very simple, and a respondent has to give the importance, relative importance to the stimulus objects. So, for example, a family is planning to go for a holiday, fixes the budget of Rs 50,000. They wish to plan the expenditures on transportation, accommodation, food, drinks and others. The constant sum is 50,000 in this example, which could be divided as transportation 10,000, accommodation 20,000, food and drink 12,000, drink 0, others 8,000. The data obtained here is numeric, but cannot be generalized beyond the list of stimulus objects. So, this data is considered as ordinal data. How come? Accommodation is rank 1, food and drink is rank 2, transportation is rank 3 and others rank 4. This technique distinguishes the objects in very less time. However, it is not useful with uneducated people or with large number of objects. We can also give another example that how, say, a student has 24 hours. So, out of these 24 hours, how much he spends in library, how much he spends with the friends, how much he spends in sleeping, how much he spends in the class. Then whatever information the student gives, there it could be ranked that the one student can give largest time to the library, then to the class, then to the sleeping, then say playing. So, if a student says that he spends 8 hours in the library and spends 4 hours for the class and he spends again 6 hours for the sleeping and again he spends say 2 hours for food and again he spends the remaining time to play. So, given his time to different activities, one can rank his preferences for spending the time. So, the data obtained again here with the student by the student in his spending daily time, although it is numeric, but cannot be generalized beyond the list of stimulus objects, that is what we gave: library, class, eating and sleeping and playing. So, the data is considered as ordinal data. This technique distinguishes the objects in less time, the stimuli in less time. So, this is a very simple way of a of a scaling technique which is called the constant sum. So, in this comparative scaling techniques, we have covered the paired comparison technique, which is also not very difficult. Then we have covered the rank order, and then we have covered the constant sum techniques. I wish I have been able to clearly explain you what these comparative scaling techniques are. Once we do it in practice, we find that these are not very tough to arrive. These are comparatively very easier, and anyone with a small knowledge of arithmetics can practice these comparative scaling techniques. In our researches, many times we require the knowledge of these comparative scaling techniques, and these are very useful, especially when we go for the ordinal data. And earlier I had already said that this ordinal data is very popular or very useful in studying the behavioral sciences. So, these techniques are these comparative scaling techniques are very useful for dealing with such kind of data. Thank you very much.